Hello friends, last video we have seen the block diagram algebra. This signal flow graphs is a continuation of that particular video. So welcome back to our Control Systems Simplified series. Today we'll discuss about signal flow graph, which is a graphical representation of algebraic equations. So let's discuss the basic concepts related to signal flow graph and also learn how to draw signal flow graphs. So this is a block diagram which we have seen. R is the input signal, and E is the error signal, B is the feedback signal, and H and G are the gains of these blocks, and C is the output signal. The same block diagram, we can represent it as in this way, as in a signal flow graph. We have R, we are taking it as one node, and E, we are taking another node, C, we are taking another node, B, we are taking another node. Right? That's example A. So a node is a point which represents either a variable or a signal. There are three types of nodes: input node, output node, and mixed node. Right? That's exactly what we will see them in this. Here the gain from R to E is 1, and E to G, here the gain is G, and H is the gain here. Okay, so these are the branches. So this is how we understand the signal flow graphs. So let's understand the terminology. Node is a point which represents either a variable or a signal. Input node with only outgoing branches. Output node with only incoming branches. Mixed node is the one which has both incoming and outgoing branches. Path means a traversal of connected branches as per the direction of the arrow on the branch, such that no node is traversed more than once. So forward path is nothing but a path connecting the input and the output node. Loop is a path which starts and ends at the same node. So non-touching loops, we have loops with no common nodes. And path gain is nothing but product of gains associated with each branch that is encountered in traversing path. Let's understand each one by one in this pictorial. So if you consider this signal flow graph, and we have the nodes are Y1, Y2, Y3, and Y4. Okay, so Y1 is the input node, and Y4 is the output node, which has only the incoming thing. Y1 is the input node, which is only the outgoing thing. And Y2 and Y3 are mixed nodes. Okay, where mixed nodes are nothing but we have both incoming and outgoing. So a branch is a line segment which joins two nodes. This is the branch. Okay, it has both gain and direction. Gain is the A, and this is the direction. And for this branch, Y2, Y3 branch, the gain is B, and the direction is this. And for Y3, Y4 branch, the gain is C, and the direction is this. For Y3, Y2 branch, the gain is minus D, and the direction is this. That's the brief terminology of the thing. Now let's see how to construct a signal flow graph for all these equations. So this could be a typical differential equations which we are putting in this form. Y2 is equal to A12 Y1 plus A42 Y4, and Y3 is equal to A23 Y2 and A53 Y5. Y4 is equal to A34 Y3, and Y5 is equal to A45 Y4 and A35 Y3. YC is equal to Y6 is equal to A56 Y5. So we have 6 nodes in this all these 5 equations, which are nothing but Y1, Y2, Y3, Y4, Y5, and Y6. So we have 6 nodes, and we have 8 branches in this signal flow graph. And the gains of all these branches are A12 is the gain of a branch 1, 2, right? Y12, Y2. That's the gain of the, that's how we terminate it as A12. Similarly, A23 is the gain of the branch from Y1 to Y2 to Y3. A34 is the gain of the, so this also says that the, you will see that the direction is from 3 to 4, and the gain is A. So A45, we have the direction from 4 to 5, and gain is A. And A56 is the gain, which has a direction from 5 to 6 with a gain of A. A42, you'll see this is a reverse direction from coming from Y4 to Y2. That's the gain here. So A53 again direction from Y5 to Y3, and A35 is nothing but direction from Y3 to Y5. So let's understand each one, how to draw the signal flow graph for Y2 is equal to, this is a step 1, A12 Y1, A42 Y4. You will see here Y1, we are putting the nodes basically Y1, Y2, Y3, Y4, Y5, Y6. So we are putting basically all the 3 nodes. Then for this equation, Y2 is the output, and this is for this input is Y1 and gain is A12. So A12 and Y1, this is how we draw from this to this. Then we have another one, Y2 is again the output for A42 Y4. So from Y4 is the input for this, A42 is the gain from 4 to 2. This is the direction. Y42, A42 means this is Y42, Y2 is the direction. So this is how we draw the signal flow graph for Y2. And similarly, if you take next step, we are drawing from for Y3, A23. So Y3 is the output here. Y3 is nothing but A23 times the input Y2 is here. That's exactly how we are representing. And this plus A53 Y5. So Y5 we are coming from 5 to 3, it is coming up to Y3. So Y3 is the output. Y3 is nothing but A53 times Y5. That's how we represent the signal for this. In the third equation, we have Y4 is equal to A34 to Y3. So Y4 is the output and A34 times Y3. The direction is from 3 to 4. That's exactly what we see in this equation. So next equation, Y5 is equal to Y5 is equal to A45 times Y4, because direction is from 4 to 5, and A35 times Y3. Y3 A35 times. So the direction is from 3 to 5, Y3 to Y5. That's exactly how we understand. Then the next equation, Y6 is equal to A56 to Y5. So we have Y6. So Y5 times A56 times Y5. That's the input here. And the direction is from 5 to 6. So these are all the represent. So if you draw the overall signal flow graph for the entire system, this is how we represent. We are just combining all these equations, then we will get a resulting signal flow graph. Now to convert the block diagrams into signal flow graphs, and these steps are followed basically. Represent all the signals, variables, summing points, and takeoff points of block diagram as nodes in signal flow graph, which is we have seen. Then represent the blocks of block diagram as branches in signal flow graph. Then represent the transfer functions inside the blocks of block diagram as gains of branches in signal flow graph. Then connect the nodes as per the block diagram. If there is connection between 2 nodes, but there is no block in between, then represent the gain of that branch as 1. Between summing points and takeoff point, between input and summing point, between takeoff point and output, if there is no specific gain, you have to consider it as 1 only. And this is exactly what we have seen. So here, if we have to convert this into a signal flow graph, represent the input signal R of S and output signal Y of S, of block diagram. And this is the input node and this is the output node. Now just for reference, the remaining nodes Y1 to Y9 are labeled in the block diagram. There are 9 nodes other than input and output nodes. That is 4 nodes for 4 summing points, 4 nodes for 4 takeoff points, and 1 node for the variable between blocks G1 and G2. Okay, so this is how the equivalent signal flow graph we have got. With the help of the Mason's gain formula, we will discuss it in next video. we can always calculate the transfer function of this signal flow graph very easily. And that is the advantage of signal flow graph. Here we need to simplify the signal flow graph for calculating the transfer function. So this is how we normally convert the block diagram into the signal flow graph, which is very, very simple if we follow the steps that we have discussed so far. So thank you very much.